All right, welcome back. So, again, we're only going to focus on the essentials. So I will say though that knowing how to do something like this is it's important, but it's not on the final per se. But again, all this is about changing it from logarithmic form to exponential form. So again, this is your base. This is going to be your exponent. 4 to the x is equal to y plus 3. Over here, the base is e. So you got to get used to that. And when you see ln, you know it's going to be e. This is your exponent. So e to the x is equal to y plus 1. All right, so now evaluating. Fortunately, they don't have like a really nice TI-84 like online calculator. You guys probably can figure out how to do it better than I can. So I just found this image just so you could see the ln button here and the log button here, and how it works. The TI-84 pluses, they actually have a cool feature where you don't have to do the change of base formula, but for everyone else who has a TI-83 or a TI-83 plus, I had to show you a way of changing the base. If you have a TI-84, it's way easier, but not all of us have that. So evaluating logarithmic expressions, just kind of like evaluating exponential expressions, you want to rewrite it, the log expression, as an equation equal to y, change the logarithmic equation into an exponential equation, rewrite the exponential function so they have the same base, and set the exponents equal to each other. So based on what we did last class, the only two new things are step 1 and 2. Step 3 and 4 is what we had already done. So for example, some of you guys who have the nice TI-84 plus calculators, go ahead and try playing around with this and see if you could evaluate it without doing these steps. But for everyone else, let's try and get an idea of how to change things to exponential form. So again, it said use the y equals just so that you have like an exponent equation. So just going to set it equal to y, just put it out there. And now it's going to be 2 to the y is equal to 16. And then now everything is the same steps as before. So this 16, I know, is a power of 2. So 2 to the y is equal to 2 to the 4th, which means that y is equal to 4. Or in other words, log base 2 of 16 is equal to 4. And basically what this logarithm is asking, it's a question, is what do I raise 2 to get 16? And the answer is 4. So the logarithms here are asking a question, and the way we set it up is answering that question. So the question, again, without using an equation, if you could figure this out and you are way ahead of the game, the question is, what do I raise 3 to get me 1 over 27? And some of you guys might get it like that. You might just pick it up right away. And not everyone's going to do that, and that's all right. So let's do this. All right, I'm going to set it equal to y or x this time just because I like it. And so now 3 to the x is equal to 1 over 27. And now the steps are just like before. 1 over 27 I can write as a power of 3. So that's 3 to the negative third power. That means that x is equal to negative 3. So this is a little bit different problem because of the 1/4. It's a little harder to think about it that way. But again, it's the same question. What do I need to raise 1/4 to get 4,096? That's what the question is asking us. And the way I set this up is I'll set it equal to x again. So the 1/4 to the x is equal to 4,096. And you can play around with your calculator. I would mess around with the 4. 4 to what power? It's 4,096. And the only difference is it's 1 over 4. That just tells us we're going to have a negative exponent. So now this is 1 over 4 to the x is equal to 1 over 4 to the negative 6th power, which means x equals negative 6. Again, try pausing it and coming back and do it again. With this one here, if you remember, there's also a relationship with exponents and radicals, and the 8th root of e is the same thing as saying e to the 1/8 power. So what we're looking at here is, what do I raise e to get e to the 1/8 power? And I think we know that answer. But if we're going to solve it this way, if you don't want to, think about it kind of logically, is e to the x is equal to the 8th root of e, and e to the x is equal to e to the 1/8 power, which means that x is equal to 1/8. Now here we're finding the approximate value. These are all exact values. That means if you use your calculator, if you figure out how to do that, more power to you. You're going to get a whole number or integer answer. Over here, it's approximate, which means you're going to practice using your calculator. So all that's saying is natural log of 15/3 is you would just hit that natural log button here and just do 15 divided by 3. All this is saying is you hit the log button, okay, log button, and close the parentheses after you do 23/14 and divide the whole thing by -1/100th or 0.01. And over here, just be careful how you write it. Use parentheses, okay, put the 3 in front, then use parentheses down here and divide. So this is just more of a calculator exercise, which again, it is on the Eastern Final, using just being able to put things in your calculator. There are like 1 or 2 questions like that. So just check. And this is where we, when we do our face-to-face time, or if you want to email me or a question, or have, there's like office hours for Zoom, just shoot me an email and I'll hop on Zoom and we could go over things like this. But if you have questions, this is the time to ask them. So natural log of 15/3 is 1.61. Log of 23/14 divided by -0.01 is -21.56. And 3 log 80 minus natural log of 5 all over log of 5 plus natural log of 20 is 1.11. All right, you guys lucked out, and I'm not going to say that because I know you guys would rather be at school. I would too, much rather be with you guys. So we're not doing this anymore, right? So yes, this is really tough, and every year we always bang our heads to try to figure out how to get kids to understand domain, especially domain of logarithms. But due to the time crunch and due to the fact it's not an Eastern's final, we're not going to do that. And we're not going to do this either. So we're not going to graph, although, it's good to understand the inverse relationship between logs and exponents. So the inverse is y equals, something like 2 to the x, or y equals a to the x. And you'll notice just, it's all everything's in reverse here. So it's 1, 0, a1, and 1 over a comma -1, as opposed to everything over here, which is 0, 1, 1 comma a, and -1 comma 1 over a. So, you see that nice inverse relationship between logarithms and exponents. And just to give you a feel, I'm not going to do all these because they're not on the test anymore. But y equals 2 to the x. Well, we know that is going to be 1, 0, 2. 1, 2, 0, 1. I was doing the other one. Sorry about that. All right, let's try this again. All right, so this is, if x is 0, we get 1. If x is 1, we get 2. And if x is -1, we get 1/2. And we know that exponential functions are going to look something like this: 0, 1, 1, 2, -1, 1/2. Well, logarithmic functions are the inverse of these. So instead of playing around with your calculator and trying to figure it out, you could just take the exponential one and just flip it. So this would be 1, 0, 2, 1, and 1/2 -1. So 1, 0, 2, 1, and 1/2 -1. And we see this kind of relationship here. And we know the domain is all reals for exponentials. and the range is from 0 to infinity, and there is no x-intercept, and the y-intercept is 0, 1, and the asymptote is y equals 0. Well, for logarithms, it's just the opposite of that. So this becomes your domain from 0 to infinity. This becomes your range from negative infinity to infinity. This is your y-intercept, that's none. Okay, and this is your x-intercept, and that's 1, 0. And then your asymptote is going to be x equals 0. So, there's this nice relationship here between exponential logs, and even like that symmetry that we have talked about of y equals x. You kind of see it applies there as well. All right, but that's not on the final, and we're short on time, and this is not the best way to learn, so we're gonna skip it, okay? But we are gonna go to something that is on the Eastern final, and that's solving logarithmic equations. Okay, so these are fun. I really like doing these kind of problems because they're a puzzle. They really make you think. Let's stop here. We're at the 11-minute mark. All right, we'll stop here and we'll continue this in a minute.